First thing is correlation. So we're going to talk about quantifying the relationship between two numerical variables. In the last couple of sections, we talked about the relationship between two categorical variables. And so here we're going to talk about two numerical variables and modeling numerical response variables using a numerical or categorical explanatory variable. So this scatter plot shows the relationship between high school graduation rates in all 50 U.S. states and D.C. and the percent of residents who live below the poverty line, being defined as income below $23,050 for a family of four in 2012. What is the response variable? Remember, the response variable is the variable that we are predicting. So that's going to be the y variable, that's the percent in poverty. The explanatory variable is the variable that we are using to make our prediction. That's the x, that's the percent high school graduation rate. And how would we describe this relationship? All right. It's linear, negative, and moderately strong. As the percent high school graduation rate goes up, the percent in poverty goes down. It appears to be linear. There's no obvious curved pattern. And moderately strong, it's not, a perfectly, strong correlation, but we can definitely see a linear correlation there. So correlation describes the strength of the linear association between two variables. Your correlation can be a value between -1 and +1. -1 would be a perfect negative correlation, and +1 is a perfect positive correlation. A value of 0 indicates no linear association. So this is an R value. So R is your correlation coefficient. This is an R of 0.33. So you've got a positive correlation in there, but it is not very strong. That's a weak correlation. This is an R of 0.69. So it's a much stronger correlation. It looks much more like a line. Here is an R of 0.98. So that looks a lot more like a line. That's very close to being a perfect correlation. And then an R of 1 is going to be actually a straight line. And then same thing in the negative direction. This is an R of -0.08, which is basically nothing. There's not really any correlation there. Here we have a moderately strong negative correlation, 0.64. This is a very strong negative correlation, -0.92. And then -1 would be a straight line. So, guess the correlation. Which of the following is the best guess for the correlation between the percent in poverty and percent high school graduation? So, we know that it's a negative correlation, right? Because the slope of our line of best fit is negative. So, we could eliminate all of the positive values here. Our correlation can't be less than -1, so we can eliminate E as well. And this is we said, moderately strong correlation, so we would pick B. C would be a very weak correlation. We would not see much of a line there. Which is following's best guess for the correlation between percent in poverty and female percent householder. So if we were to sketch a line on this one, it would look something like this. So it's definitely a positive correlation. So we can eliminate the negatives. 0.9 would be a very strong positive correlation. We would expect that to be very close to being on a line. But 0.1 would be basically no correlation. We would expect that to not look very much like a line at all. So this is probably 0.5, where we see a positive correlation, but it's relatively weak. Which is following has the strongest correlation, a correlation coefficient closest to 1 or -1. Right? So again, the closer it is to 1 or -1, the more it's going to look like a straight line. So the correct answer here is B, because this is the closest to the straight line. C and D are have more variation about that line. A, there's something going on here, but it is not a linear association. We could not use a linear model to describe this. And so we would not get a correlation coefficient close to 1. You would have to do a different kind of model in order to deal with the data in A. And that is beyond the scope of this course. But if you take more stats classes in college, you will learn about things like logarithmic regressions. And that's it for correlation. Wasn't that easy? Next, we'll talk about least squares regression line.